So in this video we'll cover solid mechanics. In particular we'll cover centroid. Centroid is similar to the center of mass, and if the force is applied at that point, then no rotation will occur. So it means that at that point at the centroid no rotation will occur. And for different shape it varies, and it can be relative to the x-axis or y-axis, and it's respect to a reference point. For a single shape, this is center is respect to the origin. For a composite shape, we just use the formula. And for example, here you can see that the centroid for the x-axis is 7.5, but for the y-axis it's relative to the reference, so it's like 6 plus 2.5, which is 8.5. And similarly here the centroid is relative to the origin, so it's like 4 plus 1.5 is 5.5, and in the y-axis is just 3. So that's all you need to know for this. And as I said before, for a compound shape made of multiple figures, this is the formula. So for the y-axis we have the sum of centroid of the particular shape times the area over the area of each of the shape. So you do centroid of one times area, centroid of the second shape times area, centroid of the third shape area, and then at the bottom you do the sum of the area of all the figures, and that's how we get the centroid of the whole system just in the y-axis and centroid of the whole system in the x-axis. And this can be a shortcut that can be used to find quickly the centroid and all the values that we need to find. So now we'll talk about the moment of inertia, and inertia is about laziness, so how easy or difficult it is to move something. So if the moment of inertia is high, it means it's very lazy, so it's difficult to move or to stop the object while it's rotating. And if the moment of inertia is low, then it's like easy to move or easy to stop. And we have first moment of inertia, which is force times distance, which is equivalent to torque. And second moment of inertia is mass times distance squared. So we just do mass times distance squared, and it has a more physical meaning. And in solid mechanics, we more focus on the geometrical parameter rather than the physical meaning, which is the angular acceleration, which is used in. You have to know for moment of inertia. And each figure have a different type of formula. For the most common one is the rectangular, which is half 1/12 base time height cubed for the x-axis, and for the y-axis just the opposite, if it's a y-axis then you cube the base. So that's how you do it. For the triangle, same, semicircle, composite. And if you want to find the second moment of inertia of composite beam, then this is the formula that we use, where I is the moment of inertia of the shape, A is the area of the shape, and D is the distance from the reference point. So is the center of the whole system minus center of the individual shape. Now to find the total moment of inertia, we just do the sum. Let's say we have a figure made of 3 shapes. We just do moment of inertia first shape, second shape, third shape, and that's how we find the total moment of inertia. And this is the best formula we can use. And just to let you know, D is the most difficult part, because it's the difference between the center of the whole system minus the center of the individual shape. Now we'll talk about composite beams who are made of 2 different materials, for example wood and aluminium, and our goal is to make only one material. And what happens is we replace the stronger material with a large amount of the weaker material. And these are the properties that remain same while we're doing this change. So radius of curvature, strain distribution, boundary condition, bending moment, and of course stiffness. And so the first thing we have to do, we need to find the stiffness has to remain the same. So we find this ratio, so stronger over the weaker material. And as we get that number value, we need to find out the new width of the stronger material, which is of course bigger. So we do the ratio times the original base. So we find the new width, and we redraw the shape, and then we find the centroid of the whole object, the second moment of inertia of the whole object, and then once we found that, we can find the bending stress of the stronger and weaker material. So this is the formula for the weaker material, and this is the formula for the stronger material, which is quite straightforward. And just to let you know why is the difference between the specific point required in the question and the centroid of the whole system. So that's what you have to remember.